Hello everybody and welcome back to the 2000 Fermat. We're on to question number 12, which says, if the expression 15 to the power of 6 times 28 to the power of 5 times 55 to the power of 7 was evaluated, I'm no English major, but shouldn't that be were evaluated? Oh well, if it was evaluated, it would end with a string of consecutive zeros. How many zeros are in this string? Alright. So, to end in a bunch of zeros, to end in 1 0, you have to be a multiple of 10. To end in 2 zeros, you have to be a multiple of 100. If you're going to end in 3 zeros, you have to be a multiple of 1,000, which is 10 to the power of 3. And if you want to end in k zeros, you have to be a multiple of 10 to the k. Okay? Let's get ourselves a new piece of paper. So to end in k many zeros, must be a multiple of 10 to the k. So what's the largest power of 10 that goes into this number? Well, it's very difficult to figure out. We can't exactly multiply this out. I don't think calculator is going to handle this. Although, let's check. 55 to the power of 7. Yeah, that's already way too big for my calculator to handle. So, if we want to figure out powers of 10, the best thing to do, and something we can do for every number, is to break it down into its prime factors. So 15 to the 6 times 28 to the, I can't remember, I think it was 5. And 55 to the power of 7. Alright, let's just double check that that's what it is. 15 to the 6, 28 to the 5, 55 to the 7. Okay. Well, 15 is 3 to the power 1 times 5 to the power of 1. We don't forget our raising to the power of 6. 28 is 2 squared times 7 to the power of 1. And 55 is 5 to the power of 1 times 11 to the power of 1, all raised to the power of 7. Now, if we have exponents outside the bracket, then it comes in equally, we bring it in and it becomes multiplication. So exponents raised to exponents becomes multiplication. So really what we're looking at is 3 to the power of 1 times 6 times 5 to the power of 1 times 6 times 2 to the power of 2 times 5 times 7 to the power of 1 times 5. Now we bring this 7 in here. 5 to the power of 1 times 7 and 11 to the power of 1 times 7. So we can simplify 3 to the 6, 5 to the 6, 2 to the power of 10, 7 to the 5, 5 to the power of 7, and 11 to the power of 7. Now I notice I have multiple copies of 5, so it's best to bring them together. And we'll rearrange everything so it's in a nice order. 3 to the 6, 5 to the 13, and, oh, we forgot 7. 7 to the power of 5, and 11 to the power of 7. Now we want to see how many copies of 10 do we have in this number. Well, you never use 3s when you make 10. You never use 7s. 7 is not a factor of 10. Neither is 11. The only things that make 10 are a 2 and a 5 together. So how many copies of 2 do we have? 10. How many copies of 5 do we have? 13. For every 2, we need a 5. For every 5, we need a 2. Well, there are more 5s than there are 2s, so we're really limited by the number of 2s we have. So we group together those guys. 3 to the 6 times, what's left over? 10. So we subtract off 10 from 13, we get 3. 7 to the 5, 11 to the 7. And this is 10 copies of 10. And that means we're going to have 10 zeros. 10 zeros, and hopefully that's one of our answers. And it's A. 10 zeros, giving us answer A. Alright. So join me in the very next video for question number 13. Thanks for watching.